So as you know, for the past week or so, I have been working on implementing the self-hosting part of the language, and we have finally managed to achieve that, which is pretty awesome. And yeah, the thing is that I thought that because what we had to do left was just the AST, and I showed you guys how to implement a bit of the AST. But then I had to also implement the preprocessor because we have a lot of auto-generated stuff like the data types, have initializer and field getters, and trust me, that was insanely painful. Like you won't believe how much stack code I had to write. Yeah, it's disgusting, but it is what it is. And I also added type checking, which honestly it's extremely slow, but I'd say that without type checking, this entire endeavor would have been impossible. Like if we didn't have type checking in the C compiler, this would be absolutely like a disaster, right? And I still want to add a few things, but I'd say that right now the compiler is complete. It can compile itself. The compiled version works, right? And just looking at the number of lines, we are it's almost the same. It's a bit more, but it's almost the same thing. And I think that's pretty interesting, right? How because in a way stack is kind of similar to C, because if you think about it, I had to go into the C code, right? I had to go into the C code, take one of the functions, like for instance type check, and I just translated the C code into stack code. So that's why it maybe looks a bit similar, like the approach, because the syntax is completely different, but you get the idea. So yeah, like what now, I mean, we should take a look at what self-hosted means, right? Because it's a bit it sounds a bit like, I don't know, Inception. So as you can see here, we have a main.c file, right? And this main.c file is used to read, oops, it's used to read the stack file, right? It can we can actually run make, and this will actually run clang on our main.c file, and it will compile it to a main executable. And then we can take this main executable and we can run it on examples. For instance, 04 rule 110, and we can just execute it on rule110.sl, right? And rule 110 is just a bunch of stack code, right? So we execute it on rule 110, we generate some assembly, then we run FASM on that assembly, and we link it into an executable. And if we run it, we get rule 110. But the thing was that, you know, main is written in C, and I wanted to have something that's actually written in stack itself, and we can compile that file into an executable and then use that executable instead of the main file, right? And we actually have this stack SL file, which is exactly the same thing as main.c, but written in stack, right? So it has all the command line arguments, it can read from a file, it runs the lexer, it runs the parser, it does some preprocessor stuff, then type checking as well. Type checking that yeah, that was yeah, you don't even want to know, but it was crazy. And then it does the assembler, right? So how does that work is we run we run the main compiler on stack.sl and we generate the assembly, right? So we do that, and if we take a look at slc.asm, we have a bunch of assembly, right? And this assembly, if we try to find main, is gonna be basically the assembly for this file, for stack.sl, right? It makes sense, I hope. And it's, I mean, it's huge. It's 37,000 lines of assembly, which quite a lot. So we have this slc.asm, right? And then we use FASM to generate the object file. So now we have slc.o. And if we take a look at the sizes of these things, let me just copy paste this command as well. You can see that stack slc.o, it's pretty huge. Stack SL, it's kind of the same size as main.c, right? They are quite similar. slc.asm is the assembly. We don't generate the main.asm because we generate directly the main executable from main.c. We don't even generate the object file. We just went one step because not important, right? And here we generate the slc executable by linking the object file. So we run that and we just got an slc executable, right? And this executable comes from this stack.sl file, right? So it's written in itself. That's the important part. And what that means is if we run on rule 110 with the slc, is that we actually compiled the example.asm, and I mean example.whatever, rule 110.sl. We generated the assembly, and then we run the same stuff like FASM and LD to generate the example. And now this executable comes again from the same rule 110 file, but it's compiled using slc, so it's compiled in itself in a weird way, right? And we can also just, so if we run this thing, we get, I mean, I wanted just to compare the example stuff, right? So it's like 26K when it's compiled using the, C compiler, right? It's like 116K and 65K. And if we run the SRC compiler instead, it takes a bit more time because, as I said, type checking is kind of slow. But we have, it's kind of the same thing. It's a bit bigger here, but it's the same thing almost. So yeah, that's the idea. And maybe for the but what about running it? Like, what would happen if we run slc on stack.sl? So it's like running, we generated an executable from stack.sl. What happens if we run that executable on its source, right? So it's like the egg or the chicken. I mean, yeah, that's kind of funny. I don't know why I had that in mind, but it's like we run slc on SL file, which is its source. We generate some stack assembly, right? This is gonna take some time because it's extremely slow. Just take a look at how much memory it's gonna consume, and that's quite fun. Because it's unoptimized, it only uses if statements, no for loops, recursion, allocates a bunch of memory. We don't free the memory. It's extremely inefficient, but maybe we can add like automatic memory management. And I mean, I have like 32 gigs of RAM, so it's 75%. It's quite a lot, right? But what happened now is we got this stack.asm file, right? So we got this stack, where is it? Stack.asm file. And honestly, it's pretty huge. It's much bigger than src.asm. And if we take a look at stack.asm, hopefully, I mean, it's kind of double in size, 82K lines. but nonetheless, this represents the assembly for stack.sl, but it's generated using itself, right? So yeah. So now if we fasm stack.asm, it's gonna generate an object file for stack.o, and finally we can ld stack.o into stack, right? And right now stack is just the compiler itself, right? So that's kind of fun. And what we can do is just 04 rule 110. It takes a bit more time because it's again the type checking step, but it managed to compile example, right? Our rule 110. And again, if we just run it on stack.sl, and this time we throw it again into stack.asm, now it compiles itself again, right? Which is well, I should have used another file just to see that is the same contents, right? Maybe that's a good idea. But we can just take a look at the number of lines. I think it was 84k or something. So yeah, if we get the same file, then that's gonna be quite nice. So if we take a look at stack.asm, I mean, I think it was 82k. I can use slc, and let's put here a 1, stack 1, right? So we should see that these two files are kind of the same. I'd hope, at least. It would make sense to be the same file. But yeah, like right now, the next step would be to actually get rid of the C code. And we need to do one more thing before we can actually do that. So and yeah, they are the same file. So we've seen that our stack executable generated from stack itself and slc executable generated with the C compiler produce the same result. So yeah, we have successfully managed to compile the language with itself. So that's quite nice. And yeah, like you don't want to know how difficult type checking was. I mean, we can just take a look at where it starts. But man, it was something else. Where does it start though? Func stack check. Okay, here. So yeah, I mean, it doesn't look that much, but yeah, I had to introduce like a new function called pick, which is not it's a bit type unsafe because it returns a pointer. But what pick does is it takes this nth item from the stack and it clones it at the front. And why does it return a pointer is because we don't know what's at that position on the stack, right? We cannot know what's there. So it's still type checked, but it's the weak part of the, right? Because when you use pointers like this, generic pointers, that's when the language becomes weakly typed, because you have to manually convert it to the right type. But yeah, like it doesn't look that bad because of this peak, but you can imagine how difficult it would have been without it, because how do you get the 6th item from the stack? But that's beyond the point. That's beyond the point. So if we go back to main, what else do we need to add before we can have the language be actually, we can get rid of main.c, because I don't want to get rid of it before that. So if we go to our preprocessor run function, here I guess you can see that we have this stack home function stack home, and I said here that we need to get the environment variable for stack home. So how do we get the environment variables, right? That's a good point. Well, if you remember from like one of the previous videos, we had this realization that when you break on start and you run the program, you can see here the argc, argv, then it's a 0, and then it's a list with environment variables. I mean, they look a bit weird. It's like variable is equal to something, but we can do with that. It's not a problem. So yeah, that's what we need. We need to keep a reference to this thing and probably add a function like a custom function that gives us a pointer to that, right? So where should we go for that? I'd say that it's like a system function, more or less. I think it's a good idea, right, to have this kind of function and vars. So the other option is how we handle the what do you call it, the argc and argv, right? So for argc and argv, we just push them on the stack before main starts, right? So we have them, but I don't want to also do that for the environment variables, because you have to also add them, and it's kind of ugly. And if I do that at the start, it's even uglier. So I think I'm gonna just have a function that gives you a pointer to the arguments. So env vars, right? We can generate some more assembly. All right, so actually I think we need to go to the first part, which is the entry point, right? And for the entry point we might need to save. So we store argc on the stack, we store argv on the stack, and what if we store the environment variables in a variable, right? So we have this data writable. What if we take this thing, like one of these, and here we have data writable? So what if stack environment, right? And this is going to be just a pointer. So stack env is going to be a double keyword, or I guess it's just keyword on the, and it's going to be called stack env, right? It's going to be called stack env, and here we need to save that. So how are we going to do that? Well, first of all, let's just steal one of these comments, store, and I think it's called arg-e or something. I don't know, let's just call it env. I forget how it's called in C, but it doesn't really matter. And here in stack env, right? So first of all, let's just take RSP, and this RSP is gonna be argc basically, right? Oh, but we need to do it like this. We need to dereference it. So this way we get argc, right? Okay. Do you guys know if you can maybe just move it into RD, like maybe RAX or something, because we don't use RAX. Then we have here we have the start of argv, right? And if on top of argv we add argc, the number of arguments, we reach that 0, right? I'm pretty sure we reach that 0. Right. We could just slc stack.sl, stack.asm, and then do the entire loop, right? So why don't we use main? Not sure. Main would be faster, but let's just get used to how slow this thing is gonna be until we optimize it, obviously. But well, if we make changes that don't require type checking, we could comment out type checking, right? So yeah, that's also a good point. So if we break on start and we run with, I don't know, like examples 0 empty, and we just do next instruction. This is argc, so in RDI we should see, I guess, 2 arguments, right? And now we should see the beginning. We push that. Oh, something is weird. Maybe I should just run make. Right, I guess, we'll have to see how you do that actually, but why it didn't look right. SLC. Anyway, so if we take a look here, it's moving RDI. Yeah, this looks kind of not right for some reason, because I don't see this code. I'm getting right? That looks a bit weird. But why if I run slc on stack.sl, why doesn't it give me this code? Because it's in stack.sl. I was like, did I forget to save it? Nope. That's kind of strange. Right, here it is though. So I mean, that's weird. Anyway, let's gdb stack, because stack is the one that works, and we'll have break on start and then run with examples 0, right? So we just have some stuff. Okay, so here at this point we move into RAX the count, so 2, then we move into RDI the beginning of the stack. We add 8, so now it's the beginning of the argv, and now we add RAX on top of that, so we get get. What did we get? Doesn't look very good. Let's let's rerun it. Okay, so it's yeah, like first it's gonna be in RDI we put 2, then here we move that, here we move into RAX, we move a 2, then into RDI we move RSP. If you add 8 to RSP you get this thing. Oh my god, you have to add, like I add 2 but I have to multiply it with 8. Yeah, that's what I forgot. Okay, so we have to multiply it with 8. So here we also have to shift right RAX with 3. Right, so we multiply it with 8 and only then we can add these things. So let's run it back. We can, you know, grab a cup of coffee while it compiles the, yeah. You know, I mean, it's slower than Rust, so we have something to work with. But I'm curious, how, actually, that's a good point. How long does it take for Rust to recompile itself? So is our language really that slow, or is it just average when it recompiles itself? So that's a good point. That's okay, so that's really weird. So I have to run make, bootstrap the SLC, and then run SLC like this. I'm curious if I run stack itself. Because it would be annoying to have to, like, I don't want to keep main. I want to see what would happen if we only have, I don't know, the SL code. That would be the goal. So yeah. Okay, so now we have stack. So if we break on start and then run it, we should see that now we move that, we shift right, so we multiply with 8. Fuck. Shift left, obviously shift left. Okay, probably someone already knew that, but sadly I was a dumb and forgot, you know, my left from my right, so whoops. We have to wait again on, I mean, this maybe will motivate me to optimize stack code to be more efficient. But what if it goes the wrong way and I just delete type checking? You know, it's only 2 ways this can go, right? It's either optimize or remove type checking. It's becoming Python developer, but in a stack language, which, I mean, I don't see anything worse than that, but okay, so. But we are now on the 0, right? We are on top of a 0. So we have to move 8 more to get on the environment variables. So at least we know, right, that if we do another add, now we are gonna be at the right spot. Okay, let's see what would happen if we run stack on itself. So fuzm stack.asm and ld stack.o. Like, would it work to recompile itself like this? Like, I'm not really sure why SLC doesn't add this stuff, because it's literally in the file. Maybe there was something broken there, but what if we run stack to recompile itself? And I mean, I'm probably gonna rename the target to be called SLC because it's funnier. But yeah, like, why didn't it? Yeah, see, like, why doesn't it add that extra thing here? That's really strange, because stack.sl, it has that line of code. So yeah, that's really weird. Why doesn't it see it? Okay, and now it did it. So, that's a good point. Maybe, like, why do I have to run it twice? That's a good point. Maybe we can figure that out at some point, but yeah, that's really weird. Why do I have to run it twice? Anyway, so if we go now until here, we'll see that RDI now contains the variable, right? And maybe I should have done also something like move into stack env, so maybe a keyword at stack env from RDI. All right, so this should probably, like, what's really weird is I run stack executable on stack.sl, so you would really expect to see this thing. Oh, you know what? I think I know why, because stack executable doesn't have this instruction inside of it, but stack.asm will have the instruction. So that's why I have to run it twice, because stack doesn't have the instruction. Now stack.asm has the instruction, so this new stack will have the instruction. So I guess that's the point. Only stack has the instruction. So yeah, still weird. Anyway, so if we run on empty and we go next, and so on, here we save into that memory address. We should save our environment variables list, right? So that's good. So how do we get the environment variables now? Well, we can make use of something like this function. Something like this function, for instance, because it's not that big. It shouldn't be that big, I guess. It's gonna be stack function env, and this is gonna give us, so we run the same stuff, is gonna give us the environment variables pointer. So get env vars pointer. So what are we gonna do? We don't need that. Is we need to move a keyword from stack env, right? We move into RDI, the value from stack env, and then we push that thing onto the stack. All right, we push that in the stack. So that's gonna give us a pointer. Right, so we have to add this this new function. We have to add it. Oh my god! And we have to also do. So it's like a new category. It's like env, and env dot. I'm not even sure what to call it. Env dot get, for instance, or maybe it's gonna be like sys.env, sys.env, like the Python system.environment. But it makes you think that it's a syscall, so I don't like that. Maybe it's like os.environment because it's gonna be dependent on the operating systems. But you know, maybe Windows has the same way of adding the environment variables and command line arguments, so we'll see. Anyway, so we have this os.env, right? And this is not gonna work, right? Because we have to add os.env in type checker. So let's go there and add its type to the type checker. So that's gonna happen. Let's do it. So ref, right? Maybe it's similar to ref, so why not? Why not? So this is syscall 1. This is gonna be env, stack function env, right? We create the arguments. Arguments should be empty, and the returns should contain a data pointer, right? Should be a pointer. And yeah, I guess the environment variables end with a 0, so it's gonna be interesting how are we gonna manage that, because we don't really have a null pointer. We don't really have a null as a pointer. So yeah, but that's fine for now. You know, like that should probably be a function. It's a null pointer. But yeah, so this is how we initialize our function env. So if we use os.env, we should get the environment variables. So usually I go to empty and I do stuff like os.env. This should give us a pointer, and the idea is that this is a pointer to another pointer. So if we do stuff like pointer.deref, we should get let's say first env, right? So we can do stuff like so it's still a pointer, but it's a string. So we can do stuff like, let's take 10 characters and let's string.init and then string.stdout. Okay, so I think we need to compile this thing twice again. It's kind of weird. I still don't get really why it's needed. Maybe it's because we changed assembly stuff. So when we did the first pass through the compiler, it didn't write assembly. So maybe if we use depth target, it's weird. Did it look like that? I thought the first argument was something different. But maybe it's because of GDB, right? So run is like config shell build phase. We could just examine like 10 addresses from this point. So for instance, if we examine, let's say, a string from here, it's the CC, examine build phase. So it could be like a random readelf. I don't know. Right, so it's like a bunch of environment variables probably. So I could do here something like 8 pointer plus, and maybe it's gonna give us another environment variable. That's what you are seeing. Oh, it looks like that. That's interesting. Old pwd 24. Oh, and I'm curious, is it the same one each time? Yeah, it is. 0. What would happen if I say stack home and then run this? It's not there. Interesting. I mean, I would maybe make a for loop to generate all the environment variables, but who knows what if I show my password or something. Yeah, but it's gonna be interesting. How are we gonna know when to stop, right? So it's also that we need to initialize a string from a C string, right? Because right now we initialize strings from length and another and the pointer, but we don't have a function that generates a string like this. Right, so that's something we need to do. I think we have in stdlib we have string length, right? And string length works with a pointer, so we can do a dup pointer dot string length, and this gives us pointer int, and data string is int pointer, so we have to do a swap, right? We have to swap and string dot init. So this should be in here. So let's just add that function, and we can say string init dot, it's a C string, right? Well, let's call it C stir. Right, so we initialize it from a C string, and it actually shows us the proper stuff. I don't have a function that converts a string into an integer, am I right? I don't think I have that. I only have digit show, but how do I read an integer? No idea. I have to add that function. Yeah, I have to add it. Okay, I wanted to have here like put your own argument and you get the environment variable that you need, right? So imagine we do something like, so that's the pointer to arg. Oh, you know what? Stack SL. In main here we have this really nice stack args parse. And I think I'm gonna have something like this for all programs, probably. Right, with usage and arguments. So, right, and what if we have an integer for offset, let's say. And we don't even need this stuff, to be fair, but let's just delete it. So this is gonna be CLI args, right? And I don't know, we have the help, we have else, whatever here is not file name, it's gonna be offset. And I think we need less if statements. So it's only one. Yeah, it's only one. Args array and I, CLI args, parse prime. So we get CLI args in the end. I think that looks good. So we have args. So if we do something like args dot offset int show string dot std out, I think we should see something like, oh, okay, args array e. So this one wants an array, an integer. So it also, I mean, it makes sense. Okay. But why did it fail? So here we do something like the pointer size of, rotate array initialize, and then we do one, CLI init empty. Oh, so we make an oopsie doopsie here. So we should say 0 is the default value of our offset. But it's still going crazy. Line 25. Okay, so at least we know that maybe this one is fine, right? And maybe even this part is fine. So here it takes in the array, the I integer, CLI, and returns CLI. So what would happen if we swap rot dup whatever? That looks good. So maybe it's something wrong in here. Let's just remove that. Let's just write it from scratch. Wait, what? It's CLI args. So it's like a 0, right? Okay, honestly, what I'm gonna do here is probably rot prime. So we have CLI args array int dup2 swap and array.count. So now we have CLI args, like args array I, and L. So we can do stuff like less than if, else phi. And in this else case is going to be pop2. And in here we are going to do some stuff. So I guess might as well just put it like this and we'll have that. Okay. Oh, I meant stack SL. In here we have the parsing stage, which is pretty nice. So I might want to use it. So we do a dup2, we do array get, so we have args array I, and here it should be a pointer. It looks like we dereference that pointer into a C string, right? So we could just use string init C string, and we get this part. And I want to use help, why not, right? I want to have the help thingy, but then we need this else case. So we go on the else case, and obviously I said that this thing should be args array I. So we do 1 plus rot and we get the same thing, and we can just recursively call to CLI args parse. Right, but here we need to figure out a way of parsing the argument. And what do we need to do? Well, sadly, we cannot know for sure if we already had offset. So the only thing we can realistically do is just set it. So why am I duping something? I should probably just so I was doing a dupe. But see, that's weird. Why dupe? Honestly, I don't remember what I was doing here, but it worked, which is pretty funny. Oh, so I brought it to this thing, so I have to do like rot 4, and that is gonna give me array I string args. Then maybe I have to do a dupe rot args string, and at this stage we need an int.read function, and maybe this function is going to return an integer and a boolean, so we can have error checks. So we just unwrap and fail if it's so why did I still have oh, string here? I don't have that. So we have args and int, so we can say stuff like stack, or I guess CLI args dot offset dot set. So we have array I args, And I said that I want to do a rot prime, so I can have something like this. So yeah, we don't have int read yet, but if we run this thing, it should say that, oh, stack args, here it's CLI args. Yeah, and type checking is not really the best. Like, the rest of the errors may be influenced by the first one, so int.read is not defined. So let's go to stdlib and let's try to implement this int.read. Takes in a string and an integer. So I guess if it's an empty string, we can return a 0. It makes sense. So we can do a dup string dot, or I guess nothing, string dot equals. If that's true, we still have a string left, so we can just pop it and return 0. Else we have to do something like int.read prime. And I think I'm gonna pass it a 0 as well, so we know at what index we are. Or maybe it's gonna, no, I think it's fine to use an index. So function int.read prime is gonna take in index and string. And you know what? It should also take in the result. So it's gonna be I string result. So here we should say 0, 0. Or I guess swap 0. So 0, we swap I first, and then we put the result at the back. Yeah, makes sense. So we need to maybe rot prime the result at the back for a second. Do something like dup2 I string string dot length. If it's less than the length, that's good. If it's too big, we do a pop2 and we just return the result. But if we are here, we can do something like dup2 swap and then string at. So string at is gonna give us, where is string at? Is gonna give us the character at that position. So that's gonna give us the character. So we are gonna have the result, index, string, and a byte. So now it's interesting, what are we gonna do with the byte? I'm pretty sure we have some functions like is alnum, is digit, right? So we have is digit. So we can just dup byte.is digit, and I guess if it's digit, it's fine. If it's not digit, it's not fine. Oh, and you know what? We have to also return a boolean here. So we have to return the OK, which here it's OK, right? There it's the OK case when we reach the end and it's all fine, it's all good. But here, if it's not a digit, right? If it's not a digit, we have to. So at this point we still have I, string, and the byte. But if it's not a digit, we can just kill it. So it's pop3 and false. Right. But if it is a digit, we have to subtract 0 from the byte. So we have to do byte 0 minus. So this is going to give us result, I, string, and digit, right? And how do we add this digit? Do we multiply with 10 and add the result, or do we do the other way around? I think it's the other way around, right? You multiply the result with 10 and add the digit. So if we had the string like 1 2 3 1 10, yeah, that's the way to do it. So we wrote for 10 multiply, so we have I string result with a 0 at the end, right? And the digit. We do a plus, so we have I string and the new result, so let's just say result prime. And it looks like we are good to just call this recursively, int.read prime. And this is gonna give us result and okay. So that's how we do an int read. It looks kind of decent, I'd say. It's sure, with for loops might be nicer, but recursively it's okay. Let's see if I was right with this crap. So, oh, we already have int read. Perfect. So if we just run this thing with 69, fuck, function not, where is that? Line 25. Wait, what? Oh, I said here it should be also boolean. So here it's pop0 true. Yeah. So let's run this thing. Oh shit. Right. Let me just comment this thing out. Oops. Function main. And if I do like 69 int read unwrap in.show string.stdout. How is this not gonna work? Damn it. Yeah, I didn't really want to, you know, do any GDB and stuff, but let's see where it's seg faults. So if I do continue, do I recognize this thing? Hard to say. It looks like it's I'm not even sure what it does. There is a compare. It jumps to I'm not sure. I'm not sure I know what's going on there, but let's try again. So we run this entire thing. We then step into main. So I'm pretty sure it's gonna happen in read. Like that's for sure what's happening. Okay, so it happens somewhere in read. But I'm not sure why. So if we do something stupid like string.std out, like printf debugging, because to be honest I think it's easier to just printf debug this thing. Oh yeah, I forgot the, you know what, the 1+ for our I forgot to increment I. Yeah, that's that can happen. 690 obviously, because we have the 0 status code, but that looks good, right? So we get the 69 as we said. So in here, what if we take this offset, we put it here, we 8 multiply, it's not really gonna work, so I have to do it here maybe. So this we get integer and we swap. So this is gonna give us like 0th one, first one, but I can just say example 2, example 3. No, like I'm just curious about our environment variables. What's the 69th one? Is there a 60? There is a 69 one. 70. Is there a 100? Is 150? No. So let's do some binary search. 140. Okay, it doesn't look like a password. Imagine you are watching the video and suddenly you see like a cat. You'll know that something bad happened. But yeah. Okay, it looks like we only have 148 variables. But if I export stack home and okay, let's export stack home and run example with 149. But how do I I'm like, what? Stack home. But it's defined, right? So where is it? Why isn't it in the environment variables? That kind of sucks. And as I said, we should do a for loop and try to find the environment variable, right? Because otherwise it's I don't know how we are. I'm not sure if it is in this list. Oh, we can do like arbitrary 170. Yeah, but I don't know, like doesn't look like yeah, not sure, but maybe it's in one of those, right? So we could have a for loop and try to find the stack home. Maybe it's also because of the shell I'm using. So if I start bash and I export stack home is equal to dot and I just run example 0. Oh, example 1. See, it looks different. But yeah, not sure. So maybe it's in one of those, maybe it's like alphabetical order or something. So yeah, best way to find it is to just have a function, and let's say os.env.get, right? So this is gonna get a string, and this is gonna give us like string and boolean if we found it. So I'm probably gonna need a get prime, which is gonna have the index that we currently reached. So let's say it's gonna be 0 swap os-env get prime. And yeah, sadly we don't have a way to stop, so we are just gonna segfault once we are done. But yeah, so let's do something like os.env. First, let's do actually swap 8 times. So this is gonna be I and string. So here we have the string that we search and I times 8. Then if we do os-env, we swap, we pointer plus, we should get string and pointer plus I times 8, for instance. Here we need to have a to do check if null. Right, it's like check if null, am I right? Or I think I have to do pointer star first, so we get string and pointer at I times 8. So that's how we get the pointer, and now we have to check if it's null, so if it's 0. But I'm not sure yet how to do that. I might need like a function or like pointer equals to check if it's null. Or like, I don't know, convert pointer to integer somehow, but we don't have that. So yeah, anyway, at this stage we should be able to do like string init cstring, right? And this is gonna give us, but I lost I have to dupe. We still have I, right? Because we need it. So at this point we have string I and the environment variable. I saw that most of these environment variables have an equal, so I'm pretty sure I can have a function that splits on equal. So let's go in stdlib, or actually let's just do it here, because why not? Let's do something like function split, string split, right? So function string split should take in 2 strings and should actually return 2 strings as well, or I guess, yeah, and the second string can be empty. That's how I'm gonna do it. So it takes in a string, a separator, and it's gonna give you a tuple with the first match and the rest. So if it's not gonna match, it's not gonna do any rest. So yeah, that's the idea. So how are we gonna do this thing? We also need a function that checks if a string starts with something. But I mean, to be honest, until then, let's just print these environment variables. So string.stdout, and let's just see if it's there, because if it's not there, then somehow it sucks. Right, so here we do 1 plus, let's not forget about the 1 plus, swap os env get prime. And I mean, thinking about it, this should actually work. So let's do something like, I don't know, os get env, and or it's env get pop to 0. So if we stack the example, main int pointer, okay, let's just remove the environment variable. So we got all of them, right? I mean, I'm pretty sure it's not gonna be passwords in here, but if it is, yeah, nice to have you on my computer as well. It's good to have a teammate. So stack, oh, it is there, perfect. So yeah, we actually have the environment variable there. So we can just, the fuck, okay, we can just start to work on function string dot starts with, let's say, in this kind of function, string and prefix. So what are we gonna do here is dup to, let's say, string and prefix again, string dot len. So we have string prefix, string length of the prefix, right? And we have an interesting function called substring, which takes in a string, the index to start, and the length. So we are going to say 0 swap. So we have string prefix, string 0, and length. So if we run substring at this point, we are going to have string prefix and the prefix that we get from this string. So if we do string equals, actually, to be honest, we had only to do dup, if I'm being honest, or dup2 is fine, but this guy is useless. Yeah, anyway, so we have string and okay, so we can do swap pop, and we are left with the okay. So now we have a function that checks if a string starts with a substring. Right. So I'm pretty sure we need a string split prime int string like this. So index, string, and separator. Right. And honestly, this thing would be kind of useful. So we don't really need starts with, because string split is gonna do that by itself. That's interesting. So by the same logic, let's say, we are gonna do a dup, right? Like I want to check if starting with index I we have separator, and if we do, then we split on that position. So if I duplicate, we have string and separator again. Then we can use the same stuff from starts with to get string separator string and the length of the separator. We should bring this guy to the front, but we don't have it. That's why I was saying this thing kind of sucks, because we should do it step by step actually. So what if we just dupe and we get separator and then string length I string sep length, then I can rot for, so we get string separator length I rot for again, so we get string L and I first, right? We get the important parts first, and what do I want to do at this point is somehow duplicate my string and obtain something like so I want to have string separator and substring, right? I want to have the substring. So maybe it makes sense to, I don't know, do something like dup3 just to make things easy. So string li, string li, then a swap and the string dot substring. So we get sep string l. Oh, I also need I somehow, so I can like I plus 1 for instance. Right, so we get the substring, then I can rot pop, so we remove the L because we don't need the L. I can swap 1 plus and then rot for prime, so we do plus 1 sep string substring, but I shouldn't really do 1 plus at this point. I need to do it after we check. So I'm just gonna do a rot 4, and we have string I substring sep. I might dupe rot, so we have string I sep substring, and here we can do like string dot equal, right? And then if else phi. So if we found that I is a good split point, we need to return the string that's before I and the string that's after I plus L, right? So let's generate the two indices. All right, let's generate the two indices. Or maybe even doing something like a split add function that just gives me the prefix and the suffix, and then I have to just offset the string. That's also a good point. But anyway, on the else case, what we have to do is iterate to the next step. Let's do that because it's easier. So we swap 1 plus, right? We get string sep I plus 1. We wrote it back to the front, and we call string split prime, and this is going to give us string, which is what we wanted here. All right, so yeah, as I said, I think maybe it makes sense to have this function split at, and it's gonna make things easier. So function string split at string int, and gives us string. So how is this function gonna work is we need the prefix and the suffix. We have substring, which is already helpful, but what I'm gonna do is a dup2 so we can work with this string easier. And we need to call to string substring, right? And what parameters do we need here? We need the string, we need 0i, that's the first call. So we need to insert a 0 here. So let's do 0 swap, and this thing is gonna give us the prefix, so the string that's before I. All right, let's push it back. Let's push it to the end, and we might as well just do another dup2. So we have prefix string I, string I. Now we need to call again string substring, but this time the arguments are going to be string I and length minus I. And now it's interesting, is it length minus I minus 1 or length minus I? Let me think about it. So let's say we have string A, B, C, D, and I is 1, right? I is 1. So we just generated the string A on this side, and we want to generate string BCD on the other side. So it kind of makes sense to have length minus 1. So instead of 4, it's 3. And that's what we are gonna do. So we need length minus I, right? So let's swap. Let's do string.len, which is gonna give us prefix, string, I, and length of the string. We swap again and do a minus. So this thing is gonna give us prefix, string, I, L minus I. And would you look at that, we just have the right inputs for our string substring. So at the end of this, we are gonna have prefix and suffix, which is what we wanted. So if we come here and we do something like a rot prime to push the separator back, and we call string.split at, we are going to be left with separator, prefix, and suffix. Prefix is good, but for the suffix, I think I want to shift it with the length of sep. Why is that? Because suffix starts with a separator. So maybe just as a y, let's just do this, and no, we have to finish it, but let's just return prefix and suffix so that you can see that the suffix starts with equals in our case. So what are we gonna do here is okay, so string split, how do we call this guy? So we are gonna do 0 rot prime string dot split prime. So this thing is gonna give us prefix and suffix. Nice. Interesting. I mean, we don't really do checks, but you know, I'm just gonna do them off screen because they're like, okay, what if the string doesn't contain the separator? Yeah, that's something we are gonna do at some other stage. So here we add the equals, right, and then do string.split. String.split takes in the environment and the separator. So we'll have string I, the name of the environment, and the value. Right, and if we do something like swap, let's put like a new line maybe, or maybe space is space, string.concat, and then swap string.concat again, string.stdout. We should see environment variable name, and then the is so line 65, I made a mistake. Excuse me, what? Oh, here I said dup3. Why did I do just dup? Strange. Substring. Still here. The fuck? So it's I mean, that looks good. The fuck did I do wrong? Whoops. Okay, let's think about it. So here I did a dup. So sep string length is I string sep L rot 4. So we brought I forward. Oh, here I brought string at the front, but then I did a rot prime. Yeah, I'm not sure how I forgot to type those functions. Anyway, so okay, yeah, nice. I forgot to also put a new line just to make things look a bit better. But yeah, as you can see, it's the name is, and then the value starts with equals. So we have to remove that, right? So here, what I'm gonna do is write the separator to front suffix sep, right? And what we need to do is something similar to split ut. Well, it's actually just split ut, right? So I'm just gonna do string.len string.split ut, and we are gonna get the prefix, the separator, and the suffix. Why did I say here separator? Because if we split the suffix by the length of the separator, we are gonna get the separator in the first bit and the rest of the suffix, or maybe it's like suffix prime, right? But it's funny that like it's just logical, right, that this separator is gonna get here. So swap pop, and we are left with the prefix and the suffix. So now if we run this guy, we should see environment variable and the value. So yeah, basically now if we do a swap and what did we get? String I name value name. If we rot for group rot, we get I value string name string dot equals if else v. So I value string. If we got to the right position, we should just return the value and true, right? So we are gonna do something like pop swap pop true. So we just keep the value. But if not, then we are gonna do swap pop. So we remove the value. Then we do swap 1 plus swap. Well, I already had that. And we call recursively to get environment. Right. I mean, I'll just do here like a to do for myself. Check if I is less than string length, but that's for some other time. Anyway, so now if we run this thing, here we passed nothing, but I want to pass stack home. Okay, so we get it. Let's unwrap. And let's just say something like stack home is string, or I guess swap string concat new line string.concat string.stdout. So that's gonna give us stack home is dot. Nice. So we somehow have this these functions that we should probably add to the standard library. I'd say these are for the strings. So let's go to stdlib, and I can just plop them here. So we have starts with, cool useful function. We have split at, which is also kind of useful, and we have split by separator. Okay, it's not perfect yet, we still have to do some stuff. And yeah, the last one is os-env get, which I think I'm just gonna do at the bottom. Let's just say os. So yeah, this one is just getting an environment variable, right? But yeah, we have to check if the environment variable is null. I guess, how do we check that? It's a pointer, and like, no, the problem is that that pointer is 0, so we cannot dereference it. I could, you know what I could do is here do something like int star, or like, let's dupe it. So now we have string I ptr plus 8 times 8 ptr plus I times 8, right? And if I do int pointer, we interpret it as a pointer, as an integer. So I mean, it is a pointer, but we just converted it to an int, right? And that's the nice part about type, like weakly typed. And if it's 0, then we should stop. If it's not 0, we should do the entire thing. So if it's 0 is the base case, we should end the loop and say, okay, we couldn't find anything, so string I and the ptri plus 8. So we could do a pop3 empty false. So that's what I would do. And yeah, basically now if we come here, stack homeless, it should panic instead of crashing. I mean, yeah, the panic, the line and column macros still don't work. I have no idea, don't ask me why, but yeah. So we are on line 458. Yeah, no idea. I have to fix that, but you can see that it no longer sec faults, and that's good. But yeah, we get the stack home, so that's perfect. It means that we can do something about stack.sl, and I had to do get environment, right? So we are gonna do stack home os get environment, right? And we are gonna do something like if this is true, we don't have to do anything. So let's do not if. So if it's not true, we pop the whatever result and we put dot. So this should in fact give us the stack home properly. Nice. So if we stack the stack twice, I guess, or I don't know, we should be able to change the stack home. Right. And 0, 0 empty. This was just testing for yeah. I mean, I should do another example. Let's call it, oh, I guess I have args in here. That's just that, and let's do 06 argparse.sl. So this is argparse int pointer, and let's have something like CLI args parse args, and just, I don't know, like CLI args dot offset. That's the return code. Nice. So it compiled. Let me just rename this to 07. And yeah, I added this while and match. So I'm kind of planning to have this kind of helpers, let's just say, that match what's on the stack. So match will consume the items from the stack, and it gives you some names to use, and you know the names cannot be redefined and stuff, but then you can just use these as constants somehow. I have to figure out how to do that in a really nice way. So that's gonna be, instead of using the pick function, because pick sucks, but this has the potential to be type safe, in my opinion, I think. And then while loops, yeah, I'm not really sure yet. They are gonna be like, the while is the label, then you have the condition, and then you have the loop pool block that repeats while the condition is true. So we'll see how that goes. Yeah, so if I go into examples and let's try to compile 06 argparse. All right, if we do 69 and we echo status, we should see 69. That's perfect. And if we do help, honestly, there's nothing in the help menu, so it's not gonna do anything. Nice. So yeah, and now it's the interesting part. So we have this stack, right? What if we make a folder X, we copy stack into X, and we cd into X, and we try to run stack help? Weirdly enough, it works. Okay, stack, and let's try to do examples from this folder, right? Huh. Curious, why did it work? Because I don't have the stdlib here. So if I do test.sl function main, I just want to test that the environment variable is working, right? So if I do something like this and I stack test.sl, it generates some stuff. Example awesome, example awesome, and ld minus o example.o. Right, and I mean example will work because it's not using any stdlib. But what if we import stdlib? It panics. Probably because it cannot import the... So if I just parse it works, but if I try to parse it like this, it doesn't. And if I do stack home is like home Alex personal stack lang, and let's just keep it like this because here it's lib. And I try to parse again, it works now, right? So the environment variable is fine. So yeah, that's what I would say. Let's cd back. Let's remove the X directory. Okay, so I'd say that at this point we should be able to just remove the C. Let me just put this. Okay, and yeah, like what we did today was to add this env variables, right? Pretty simple. And in stdlib we added some extra functions, right? I just have to make sure that they are properly working with no bugs. But yeah, feature add and bugs. Right, so yeah, as I said, I think we should be able, like what I would probably do is just git clean fdx, so we remove all the crap. Okay, so right now we are somewhat, we have to run make to generate SLC. Shit. Oh, that sucks, right? I have to also add it to C code to do the entire process again. Damn, that sucks. I guess I should, well, we can try to do that next time, right? To remove the C code. And I'll just add this thing to the C code as well, because I deleted the stack. Well, I didn't even run the mix build. So yeah, it's just missing from here, right? And because of that we cannot do the entire process yet. So I'll just add it to the C code because that's just C. And next time we are gonna do like the removing the C code. But that sucks. Maybe I'll just do it in the same part after some time. So yeah, I'll just add this thing to the C code and then probably just combine the two of them. So yeah, see you then. Okay, so recovered from the silly mistake of removing the SLC executable, or any of these. But yeah, let's now finish the entire loop, right? So we ran the make with the C compiler, we added everything. We now build the SLC executable and generate the stack asm file, and we are gonna use this stack asm file as a bootstrap step. So we are gonna add maybe a bootstrap folder, and in this bootstrap folder we are gonna add the stack assembly that's getting generated. We could store the executable or something, but I think that storing the stack asm makes more sense. So now if we run stack again on itself, so we get the same file, we should copy it into Bootstrap, and let's not delete that file again. Yeah. So let me just maybe update main.c and say, oops, forgot to save Asm file, so I had to implement it in main too. Yeah, so that's the main reason. And now if we copy stack.asm into Bootstrap, we should store this thing, because otherwise maybe let's add an ignore rule and say ignore the Bootstrap. How do you do that? Bootstrap, is it like that? No, do I have to put it before? No. I'm pretty sure you can put an exclamation point to ignore some. Okay, yeah, that's how I did it. Perfect. So, oh shit. This way we just added the Bootstrap code in here. So we can just commit this thing and say feature add asm code to Bootstrap the compiler, right? And why do we need that? Because if we remove main file, we cannot do the make step. So we have to start somewhere, and you have to think about it. We start from the C code, we can start from the SLC executable, and the next logical step is stack.asm. So I think that's the best way to do it. So yeah, at this point we can just remove main.c, ds.h, and inside of make we should do fasm bootstrap slash stack.asm. So this is gonna generate, I'm not even sure what does bootstrap stack asm generate. Is it, oh, it's gonna be in the bootstrap file. Ugh. I mean, I'm not sure how you can tell fasm, like fasm help. You cannot tell it like where to dump the text, but yeah, it's fine, it's fine. So that's gonna give us bootstrap slash stack.o, and that's how we generate SLC. So now if we run make, it's gonna run it from here, but that's just the bootstrap, right? So the actual build is gonna be done by using SLC on stack.sl, and we dump that into stack.asm. Should we override the bootstrap? I mean, I think that should be a manual process, bootstrapping the assembly. We dump it here, then we fasm stack.asm, and then we ld stack.o into SLC. And to install the thing, we copy SLC into bin.dir and the library. Right. And this is gonna be just bootstrap. Right. And how is this gonna work? So all should be just build and bootstrap. I think it makes sense. Like if you don't have SLC, yeah, I'm gonna think about how I want to do this stuff. But if we remove stack, like if we remove stack, right? Yeah, and if we do make bootstrap, it's gonna it has to be funny. Okay, make bootstrap, it generates SLC, right? But if we try to make build, it doesn't find SLC because we have to run make install. Yeah, right, which makes sense. Makes sense. Yeah, but I think that's good for now, right? It can compile itself. That's good. And if we add features, right, we need to generate the assembly and move it back to this bootstrap folder. So I think that's how we are supposed to do it. And bootstrap should be ran the first time when you don't have SLC, and afterwards when you have SLC you just install it. And like this is just in case we do the same dummy mistake and delete everything, right? But yeah, I think that's how you're supposed to do it. So yeah, thank you for joining today. We just managed to remove all the C code from the project. That's good. That's the first step towards this new programming language called Stack. But you know, if you have any suggestions for the name, I'm open. But yeah, let's see in the next one.